All right, here we go. So today's objective will be to be able to interpret functions. So last time we left off, we were simply studying how to interpret whether something was a function or was it just a relation, right? And we were testing it with vertical line test, or we were also utilizing, checking the input to see how many outputs it had. And so that's where we were. Today we're headed into here's a function or here's a graph, and then can we interpret multiple parts about it? Okay, and one of those will ultimately be, is it a function or is it a relation? Okay, so we'll also take a look at domain and range, right? So kind of recap what we learned from first semester. And then we'll look for outputs, we'll look for inputs and things like that. Okay, so the graph is what it's supposed to be. All right, so one of those things about it is when you're looking to analyze something like this is to pay attention to some of those details. And if you notice here, there's details in the sense that some of these are closed circles, some of these are open circles, right? And so that means different things when it comes to the domain and the range. All right, so something to kind of notice is you see how there's a little bit of a gap here where the 2 is at. That's just because of the printing, right? It didn't want to cover up the 2, so this is filled in. Okay, right, so just to clarify that. All right, so if this is the relation or the curve that we have, the first thing we want to do is identify the domain, right? And domain is information about how far left and how far right the curve goes. And so if I look to see how far to the left the curve goes, what would you say that is? Yeah, it's -2, right? So I have an idea that the domain begins at -2, but because I have an open circle here, would I use a bracket to include -2, or would I use a parentheses to not include -2? Yeah, parentheses. Good, Neil. Thank you. Right. Parentheses because we're not including this number, okay? Because it's open, all right? And then we follow the curve all the way to the right, right? And then what would you say is the furthest to the right that the graph goes along the x-axis? Yeah, it would be 2, right? It's 2. This time, this is very clearly a closed circle, right? You see how it's filled in. So this is closed. And if it's closed, do we include 2? Yeah, we can include 2, right? So therefore we use the bracket. Okay, we will use a bracket, the one that looks like a square. All right, so that includes 2, but does not include -2. Okay, so that's domain, right? So pretty simple. We just follow open and closed. All right, let's talk about the range now. Okay, so remember, range is not left to right, but bottom to top, right? Minimum to maximum. What would you say is the minimum value along the y-axis? Yeah, it's also -2, right? So -2, that's the lowest. That's the lowest y value that we have. Okay. Now let's think about, can we use open, or can we use parentheses, or can we use bracket? Notice how this is the lowest point over here, and this is also the lowest point over here, right? So they're kind of at the same level. One of them is open, one of them is closed. Okay. Do I have a point at -2 on the y-axis? Do I have a one solid one at least? Yeah, we do, right? It's this one. If I were to give you the coordinate for this would be 2 comma -2. -2 does exist on the y-axis, okay? It doesn't exist over here because it's open, but it does exist over here, right? It exists on the right where the dot is closed. So because we do at least have one, there's one point where the -2 exists on the y-axis, then we can include it. Another way to think about it is if you have them both on the same line, one of them is solid and one of them is closed. I'm sorry, one of them is open and one of them is closed. The one that's closed overrides. Okay, if they're on the same level. Okay, if you're looking to determine, okay, on the range, can I include -2 or can I not? If I have one that's solid, that one overrides, so I have to include it. Okay. And the max, well, the maximum is I have to look at what's the y value at the peak of the curve. And what would that be? Is it 1 or is it 2? It's 2, right? So the max occurs up here, right? And that one, you can see how the curve was solid, right? There's no opening up there. There's no hole. So when we say that the max is 2 right here, that's also going to be included with a bracket. Okay. So when it comes to range, the only time that it can be a little tricky is if it's on the same line. If it's on the same line, like it is here, you just check to see, is one of them closed? Is one of them solid? Because if at least one of them is solid, then I can say that -2 is part of the range. Okay. All right. So that's it for domain and range, really. It's just trying to determine like, okay, how do I navigate the open and the closed? And then how does it work for domain and for range? Okay. All right. So now let's talk about what this represents here. Okay. This notation can be a little tricky. All right. It's asking for f of -2. Now you've probably seen something like f of x, right? So this is basically telling us my x is -2. All right, my x is -2. So when my x is -2, what is the output? All right, so what this is translating into is basically asking, what is the output? Right, what is the output when x is -2? Okay, what is the output when x is -2? So if I'm looking at the graph, well, the first thing to do is, well, where is -2 along the x-axis? Well, it's over here. So it's basically a two-step program. We go find x, you find that x is -2. And if I want the output, well, I have to go meet the graph. And where is the graph? The graph would make me have to go down in this situation. Okay. And I want to see what is that y value when x is -2. Okay, so when x is -2, I have to go hit the graph. I go down to hit the graph, but then what do I find? It would be -2 if it was filled in, but it's not filled in because it's open. So you're going to learn a new term today. It's called undefined. Okay, it would have been -2. You were on the right track. It's getting close to -2, but it doesn't actually get there because it's open, right? So when you get there, there's nothing there. So then you would state that this is actually undefined. Okay, so that's a new term to kind of consider, all right? And that'll happen sometimes because what we have here is what we call a hole. Right? This open circle can also be called a hole. So when you get there and there's nothing there, well, I have no y value. There is nothing that I can say exists there. Okay, so that will happen sometimes. Correct, yeah. All right, let's take a look at the next one, right? So again, this is like saying f of x. So what does that mean? What would be the translation in this case? So translate it into the phrase the same way I did with the first question. F of -2, what is it asking us to find? It's asking us to find an input, or is it asking us to find an output? Output. Correct. Yeah. What is the output when x is -1? Okay. So they're telling us what x is. X is -1. We need to find what's the output, right? So translate it. When we won't do this all the time, this is just for now to get used to what is this question asking me. Okay. So what is the output when x is -1? So again, two-step program, right? First, you're going to start at origin. You're going to go to -1 on the x-axis. Okay. And then if you wanted to touch the graph, would you have to go down or would you have to go up? This time you have to go up, right? So it just depends. When we went to -2, we had to go down because that's where the curve was at. But when you get to -1, well, I got to go up now. So I go up. And what is that output right there then? What would be the y value? Yeah, this time the y value does exist. It's 1. Okay, do you see that? So whenever we have these output questions, when they're asking for what is the output, it's just like directions, right? Like find the x that they're talking about, and then either move up or move down to go hit the graph. That's it. All right, does that make some sense so far? You don't have to draw the arrows. I do them because I'm trying to show you, and it's the only way I can show you visually. But if the arrows help you, then do them. If you can find it without the arrows, then you don't have to. Okay. Let's try f of 0, right? What is the translation in this case? Yeah, what is the output when the input is 0? Okay, what is the output when the input is 0? So let me translate that real quick. Okay, or what is the output when x is 0? So when x is 0 is right here, right? You don't move left or right, but in order to get to the graph, you move up, right? You have to go straight up. So you move up, and what is that output going to be, right? Tony has it already for us. Yeah, it's 2, right? So the output is 2. Okay, good. All right, and then finally, this last one. This one I'm not going to translate, okay, because I think we have an idea of what it means. But again, it's f of x. So what did they change x into? They changed it to 2. So that means we're looking for an output when x is 2. So we navigate to 2 along the x-axis. Here's 2. Where do I need to go? I need to go down, right? So I'm going to go down. This time I get to a point and it's filled in, right? So this time it will be -2. All right. This time it will be negative. Oop, -2. This is still output. Anytime you see it where it's a letter, parentheses, and there's a number inside, I'm giving you the input. So then you have to find the output. Remember that like f of x is the same thing as y. F of x is y. So they're asking you find the y value. Okay, because the other way, if they ask the question, you see how like, right, but we're going to get to it, but you see how this one says find x? It's the reverse. They're giving us the y, we want to find x. But on the first 4 that we did, they gave us x, you have to find the other one, right? So they either give you x, you find y, or they give you y, and then you find x. It's the only 2 ways that they'll give you the question. Does that make sense? Okay. All right. So that's how you find outputs. You navigate kind of using go to the x and then go up or go down. Pretty easy, right? Like it's just pretty easy to navigate. Okay, so let me erase these just to clean it up. Okay, now the next part, will there ever be an input with 2 outputs? Yes, there will be. Yeah, there will be. We'll look at some of them on the worksheet that I give you. And there will be some. Okay, and then if that's the case, if there's an input with 2 outputs, then you got to list both outputs. Okay, so now let's take a look at this one. This one's asking find x. Find x. So you're not finding the output. This time you're going to find the input when, remember, what does this f of x mean? This means when y is equal to -2, right? So when y is equal to -2, find the x value that belongs to it. Okay, so here's what I like to do. Okay, I know that the y is equal to 2. So I go down to where y is equal to 2 and I draw a line where y is -2 because y is -2 along that whole line. Okay. And then my job is, well, what are the x values that give me -2? All right, so I see that, well, I have a -2 here. I know this one for sure is a -2 on the y-axis. Okay, what would be the x value for this point? Yeah, in this case, it's x when x is 2. Okay, when x is 2. Okay, could I say that when x is -2, I also have a y at -2? Does this one count? No, that one does not count. Okay, I can't say that y is equal to 2 here because, or I'm sorry, I can't say that y is equal to -2 here because the circle is open. So that point is not -2. Okay, so you don't have to say anything else. You don't have to mention undefined. You just only list the x value where the point is -2. Okay, and then that one was only x. So you see, it's kind of the reverse, right? So you find the y, and then you go up to find what's the x. Okay, and we'll do another one right now. Okay, so a similar question. Check it out. It's asking find the x when f of x, and then here, remember, you can always change this to y, right? F of x is the same thing as y. So when y is 1, so where would I highlight? I'm going to highlight where y is 1. So I'm going to go all the way across here. This is where y is 1. Okay, I'm going to erase this one for now just so we don't confuse ourselves. And then can you tell me what x values, right? Because I see there's a point here and there's a point here. Yeah, so this time I have 2, right? I have 2 of them. So x is 1, comma, x is -1. Okay. So I start by highlighting my y value first. And then if I have points where they touch, then I just look down to find the x value. Okay. Any questions so far on this example? Okay. So a lot of it is just kind of reading the curve, right? There's not much math, there's not much algebra. So it can be kind of fun because you don't have to calculate anything. You just have to look for it. Okay. All right. And then lastly, is the relation a function? Right. So let me erase some of this. And then what do we see? Would this be a relation? Would this be a function? And why? What's the reasoning? What did we learn last week that would help us determine if this is a function or not? What test could we use? Yeah, VLT, right? Vertical line test. So if I draw vertical lines anywhere, right? Doesn't matter where I draw them. I'm only going to hit the curve one time, right? So if that happens, I only hit the curve one time on a vertical line. What do we say? Is that a function or is that not a function? Yeah, it's a function, right? So we can say it's a function. And what's the reasoning? Yeah, we can say that it passes VLT, right? Vertical line test. Okay, and that's pretty much it, right? So you'll be given a curve. You look for domain range, a couple inputs, couple outputs, and then test to see if it's a function or not. If the graph is a circle, do we immediately say no solution, or do we still? If you get a circle, you would still need to find domain range, input, outputs. But the way that you would answer the relation or function question is you would have to test it with a vertical line. So you would still have to do everything because this is only one question right here, right? And all of this can still be answered. Everything over here can still be answered, even if it's not a function. You can still answer all those questions. Okay, so you have to answer everything independently. Okay. All right, are we ready to move on? All right, so for now you can follow along, make sure you have the solutions down, and then later you can go back and just sketch out the curve so that you remember what it was that you were analyzing if you don't have a chance to print this out. Okay. All right, here's another one. This was also kind of nice and easy. All right, again, let's focus on the details of the graph before we jump into domain and range, okay? Because sometimes they look like they are something that it's not. If you take a look here at this piece, that's an arrow, okay? So that arrow means that the graph will continue moving to the left and then down, all right? So that's an arrow, yeah. And this is closed point, right? Closed, solid, filled in. Okay, so now that we know that, then now we can address the domain, the range, and all that other good stuff. Okay, so if we know that this is an arrow which continues to the left and down, how does that change the domain? What does that mean about how far left it will go? Yeah, we know that then that means the implication for the domain is that it moves all the way to negative infinity, right? It's moving to the left. Good. And then as you move, track the line to the right, how far right does the graph go? Yeah, it stops at 4, right? And it stops at 4. Can we include 4 with a bracket or parentheses? Yeah, it's a bracket, right? We know that because it's a closed circle. So you use your knowledge of inequalities. Anytime it's closed, you use a bracket. Okay. So now let's think about range. Range is minimum to maximum, low value to high value. If the arrow moves in that direction forever, what's the lowest y value it's going to hit? Yeah, it's going to keep going downwards till it hits negative infinity. So the range also goes down to negative infinity. And now you're tracking the y value, right? Right here is my y value. What is that? Max y value. Yeah, it's going to be -1. So it reaches -1. Do we include -1? Yes, right? It's a bracket. Okay. And then again, you see how this one, it looked like it cut through. There's like an opening here for -2. Again, that's just the printer. Okay, so you just kind of fill that in. Okay. How does it reach -1? So you're tracking the y, right? How tall? We're talking about this point, right? That's the max that it reaches. What is that y value? You see it? So that y value is -1. Okay. So then that's how I know that that's the max y value. Okay. Yeah. So when you're reading range, bottom to top. So you have to scan across to look at the y value. Okay. All right. So now let's take a look at f of 0. f of 0, what does that mean? What's the translation for that? Yeah, so we're looking for the y, right? What is the output when x is 0, right? So we'll do this one just once. What is the output when x is 0? Okay, so remember this is like f of x. So that's how you know x is 0. So when x is 0, we're here. I need to go meet the graph, right? So do I go down, up? Yeah, the only way to go is down. That's where the curve is at. So if I go down there, what is that y value going to be? Yeah, it's -2, right? So do you see why I filled in the curve a little bit before? Because I didn't want to have confusion about, oh, it's open, right? When it's open, it's a literal open circle. So that's why like sometimes when it's printed, if you see just the gap, that means that it just didn't want to print over the number. Okay, so that's just tricky stuff when it comes to printing. Okay. So if there's ever any doubt, you can always ask like, hey, is this supposed to be an open circle or am I supposed to shade it in? Okay. All right. What about f of 4? Right. I won't do the translation this time. Okay. But it's still asking us for output because this is f of x. So now x is 4. What is the output when x is 4? Yeah. So travel to 4. and then go down and meet the graph. What is that y value? Yeah, it's -1. Okay. Not too bad, right? Oh, okay. All right, so let me go ahead and erase this. And now let's take a look at the next question, right? So now this one is a find x question, right? Find x question. So what am I given? I'm given what the y value is, right? I know that y is going to be -2. So this is where you get to go. You're going to highlight -2. You're going to go across. And you see that there is a point where it does touch, right? What is the x value for that y value? Go up, that's right. And this would be 0, right? That x value would be 0. So x equals 0. Plus minus 0. Okay. Any questions so far? No, we're all good. Okay. So then the next thing is, now we answer the last one, right? We leave that till the end. Is the relation a function? What could we use to determine the answer to that question? What's our special test? Yeah, VLT, right? Vertical line test. So anywhere I draw a vertical line, right, I can draw it in multiple locations. I don't see that there's going to be any place where it's going to hit twice. So then I would just say that this is a function. And what's the reasoning? Passes the VLT. Okay. All right. So that one was kind of nice and easy too. Any questions about this one? Are we ready to move on? Yeah, VLT equals vertical line test. Okay, so you can use the shorthand notation. All right, we're ready. All right, let's go. Okay, a little bit trickier. Okay, so let's go ahead and let's think about what this curve is asking us or what it's showing us. Okay, so notice how it does create a little bit of a zigzag M. All right, Doritos, there you go. I want you to notice, check this out down here and check this out down here. What are the arrows indicating? Yeah, it keeps moving down. That's right. It's not even going to bounce back up. It's going to just continue straight down. All right. The difference would have been if it was going to bounce back up, which was similar to the one we saw in notes number 13, is that you would have seen it pop up like this. And then we could have assumed that it was going to zigzag back and forth, right? Infinite Dorito. Yeah, that's a good way to say it. But because we don't have that little pop up of the arrow, then we can't assume it's going to continue to zigzag back and forth, right? It's not going to make that zipper. So because the arrows only point in one direction, moving downward, then what's going to happen is we're just going to assume that this function moves forever downward to the left and the other one downward to the right. Okay. So now that we have that understanding, all right, let's talk about what the domain is for this function, right? It's moving down, but to the left. So how far left? Yeah, this is going to take us to a negative infinity on the domain. And then on the right side, it's moving down and to the right. So what do we say about the right side? Where is it headed? Well, it's moving to the right. Remember, we're domain. So yeah, it'd be positive, right? So it's positive. Positive infinity. Okay, good. Okay, let's talk about range. All right, they're both on both arrows, they're both headed down, right? So what would where would my range, what would be the minimum on my range? You see both arrows, they're both headed downwards. We're talking about range, right? So range is Y value. What's the lowest Y value? So where are they headed? Okay, so range begins or is the minimum at negative infinity. What do you notice is the maximum Y value? On the Y-axis, what's the largest, what's the peak? Yeah, it's 2, right? So you can see right up here at 2, that's where the peaks are. So that's where the range ends. And you see how they're solid, right? So are we going to include 2 or are we going to not include 2? Right? Check out these lines. They're solid, right? They're filled in. So we want to include, we want to say that 2 is part of the range. Okay, good. All right, so I'm going to erase these. Okay, so sometimes that helps, right? It seems like, why did we go through that process of extending the lines and the discussion? Is just to know, like, okay, what is this curve doing? Okay, so now h of negative 2.5, I don't want you to think h is anything different. This is the same thing as like f of x, right? What they've done is like, they've just changed the letter. So think of this as h of x, all right? But h, f, g, m, whatever, it doesn't matter what this letter is out front. It's all the same thing. Okay, so what this is asking us once again is, what is the output when the input is negative 2.5, right? That's what we care about. Okay, x is negative 2.5. So what is the output? What is the y value? All right, so let's track over to negative 2.5, right? Negative 2.5 is right around here. So we get there, and what would I need? Which direction do I need to go, up or down, to meet the graph? Yeah, let's go up. Okay, so what is the output when x is negative 2.5? Yeah, it's going to be positive 1. Okay. All right, same idea here, right? This is h of x. H of x. So what is the x value? It's 4, right? So what is the output when the input is 4, right? That's all it's asking. So let's go to 4 on the x-axis. Oh, okay. And which direction would I need to go if I wanted to meet the graph? Yeah, I would need to go down, right? So I'm going to travel downwards. And then what would that y value be at that point? Yeah, it's negative 2, right? So this one was nice. It gave us an output for both. All right. Any questions on that? Okay, good. Okay, so now we have a couple of find x questions. All right, so I'm going to go ahead and erase some of this. All right, this is where I like to highlight, right? I'm going to find x when h of x, and again, you can just translate this, when y is 1. Okay, so when y is 1, this is when y is 1, so draw the line right through it. Okay, and let's find how many points it crossed. Right, so I see 1, 2, 3, 4. Right, so it looks like there's going to be up to 4 x values that give me y is 1. All right, what do you think those x values look like they are? Right, if I were to go down, mark the x-axis. Okay, so the first two on the left side, yeah, it looks like it's going to be x equals negative 2.5 and x equals negative 1.5. Okay, and then what else? On the other side, right, it's almost the exact same except the positive version. So we have x equals 2.5 positive, x equals 1.5. Okay, so in this case, we had up to 4, and that's okay. That happens. All right, any questions on that one? All right, I'm going to erase it because we have a similar question underneath and I want to make sure that it's clear. So we're finding x again, but this time when y is equal to 2, right? So I'm going to go look at when y is equal to 2. I'm going to highlight it. So here is when y is 2. So I'm going to highlight the whole the way across. And I notice there's also a couple of intersections on that y-axis. All right, so I see it here. I also see it here. Okay, so if I were to go down, what is the x values? What would you say? Yeah, you want to list both of them. Okay, so we have x is equal to -2 and x is equal to 2. All right, and then last one. Okay, I have another find x question. Okay, so find x when what? This time when the y is equal to -2. Okay, so let's go find -2 on the y-axis. Here's -2 on the y-axis, so that means I'm going to draw a line all the way across. All right, how many different x values do you think we're going to find for this question? Yeah, it looks like we're going to find 3, right? I see 3. So here's one, here's another, and here's another. Okay, so let's go up, let's track the x value. All right, so what are my 3 different solutions? Okay, x is 0 is one of them. X equals -4 is the other. And the final one, yeah, x equals 4. Okay, and that's the last question for interpreting. All right. So what do we say finally? This is the relation a function? What do we want to test it with? VLT, yeah. So what do you think? I can draw vertical lines pretty much anywhere I want. Do you see any conflict where it's going to cross the graph twice? Yeah, this looks like we're going to end up with a function, right? So even though it's zigzagging, right, it's still a function because it's not going to cause the curve, or it's not going to cause any vertical line to hit the curve twice. So this would be a function. Passes the VLT. Okay, any questions on this example? All right, we got one more and then we'll be done. All right, cool. Let's move on then. Okay, here's our last one. All right, so here's a curve. This one's probably the most familiar to you. What kind of function does this curve remind you of? Yeah, parabola, right? And so what functions create parabolas? Or what family of functions? We studied them in the fall. I'll give you a hint. It starts with a Q. Yeah, quadratic. Yeah, there you go. So quadratics create parabolas. So this is probably a quadratic, right? It just got chopped, right? It got chopped. So this might be familiar to what you're doing on Desmos, right? Like you have a parabola and then you got to chop it, so you only see one part of it. All right, so let's take a look again. Let's analyze, make sure that we're on the same page here. What do we have here? Open circle, right? That's a hole. You can either label it as a hole or it's open circle. Okay, what do we see up here? Is that a point or is that an arrow? It's an arrow, right? So that's important because it means that this will continue upwards and also to the right. Okay, so now let's talk domain. right? How far left does the curve go? Left. How far left? This way is left. Yeah, it gets to -2, right? But at -2 itself, it's undefined, right? Well, at least how would we represent that with a domain? Do we include it with a parenthesis or a bracket? Do we not include it? Yeah, this would be parentheses, right? We can't include -2 because it's an open circle there. So technically it's not even there. All right, and then as we move to the right, okay, track the curve to the right. Which direction is that headed in? Yeah, this one is headed towards the positive infinity. All right, so that's domain. All right, now let's talk range. What's the minimum y value that you see? All right, what is that y value? Yeah, that'd be 0, right? So for range, I want to say that's 0. It's solid, right? The line is solid there, so we can include it. All right, and then what would you say is the -8? We're talking range, right? So we've already talked about the minimum value, the minimum y value. What is the max y value now? Okay, it's an arrow though. So if it's an arrow, it continues, right? So it doesn't stop at 8. Okay, so it continues up towards positive infinity. Okay, so yeah, that's the tricky thing, right? So that's why we talked about that this is an arrow, because if it was a point, then it would stop at 8, right? It would stop at 8, but because it's an arrow, we continue, it's going to reach positive infinity. Okay, and even though we had a conflict here, right? Check this out. Open circle here, but then if you go across, this was solid, right? So we didn't even have to think twice about it. It was solid on one side, so we knew like, oh yeah, it's going to continue. We don't have to break it at 2, right? Even though it's a hole on one side, it's closed on the other side, which allows the continuous path upwards up to infinity. Okay. So I just wanted to point that out. All right, what do we think with g of -2? What are we going to get there? G of -2. So again, they've changed the letter on you once again, but it's the same as saying g of x. So when x is -2, what's my output? Is it 2 or is it undefined? Yeah, it's undefined. And why is it undefined? It's an open circle, or there's a hole there, right? There's a hole. It does not include 2, correct. So then this would be undefined. Okay, good. What about g of 4? G of 4. What does that mean? That means that x is 4. So we go over to x being 4, and then I got to track upwards to meet the graph. What is that output going to be? No, this one's not infinity. What is the actual point when x is 4? There is a point there. This one is 8. Okay, this one is 8. The arrow just indicates like you could continue to draw the curve, but there's going to be a point there. Okay, it doesn't mean that like suddenly it's infinity. It's just giving you the trend of where the curve is going. Okay, so the trend is useful for domain or range, but when it comes to evaluating, you would have to find the actual output. What is the actual y value? All right. Okay, now we have a couple of find x questions. So let me erase some of this. All right, find x when g of x is equal to 2. Okay, so find x when g of x, and then in this case, g of x means y, right? When y is 2, right here, find x. So I'm going to highlight. Okay. what is the X value, right? Because I see it crosses here and then potentially here, but which one of them is the valid one? Which one of them actually exists? Yeah, it's when X is 2. Because on the other side, I have a hole. So Y is not 2 at this point. Okay, it's only 2 at this point. So that's why we focus on this one only. When X is 2, that's when Y is 2. Okay, let's talk next question. Find X when G of X is 0. So when G of X is 0, that just means when Y is 0. So here we're talking down here. All right, so that's when Y is 0. So I would draw this. What would be the X value then? Yeah, when X is 0, right? When X is 0, Y is 0. You have your point here at the origin. Okay. All right, and then finally, when find X when Y equals 8. So up here, when Y equals 8, draw your line. Okay, I see that there's the point right there, which means what is the X value? Yeah, the X value would be 4, right? Got to go all the way down, find that X value. X is 4. Okay, and then real quick, is the relation a function? Right, take a look at that graph. Yeah, it's a function, right? What's the reasoning? Yeah, it passes VLT. Okay. And then that's it for examples. Okay. So what you'll have for homework tonight is an IXL. What we'll do when we join class on Friday is I'll give you time to practice, do classwork, then we'll review answers. Okay. So I have a set of questions that we'll do. Okay. And we'll begin that, or we'll do that, and then I'll review the answers.